Hello everyone, I am Isha Kumari from Sri Venkateshwara College of Engineering, Bangalore from the Department of Computer Science and Artificial Intelligence, and here is a presentation on machine learning. So today's topic is SVM and its kernel types. So introduction to SVM. Definition of SVM. Support vector machine is a supervised machine learning algorithm that can be useful for both clarification and regression challenges. However, it is mostly used in classification problems. History and development. Developed by Vladimir Vapnik and Alexei in 1963, SVM became popular in the 1990s. Application of SVM widely used in image recognition, text categorization, bioinformatics, and other fields requiring predictive modeling. How SVM works. Concept of hyperplanes. A hyperplane is a decision boundary separating different classes in SVM. In n-dimensional space, a hyperplane is a n-1 dimensional subspace. Margin maximization. SVM aims to maximize the margin between the nearest data points of different classes, which are called support vectors. Support vectors are the data points nearest to the hyperplane. They define the position and orientation of the hyperplane. Mathematical formulation of SVM. Objective function. Minimize half subject to the formula given for all I. Constraints. The constraints ensure that the data points are correctly classified with a margin of at least 1. The optimization problem. Lagrangian formulation. The optimization problem is often solved using the Lagrangian formulation introducing Lagrangian multipliers. Linear SVM. Definition and properties. Linear SVM is used for linear separable data. It finds the optimal hyperplane that separates data points of different classes with a maximum margin. Application. Used in text clarification, image recognition, and other application where data is linearly separable. Advantage and disadvantage. Advantage include simplicity and efficiency for linear separable data. Disadvantage include limitation in handling non-linear data. So now coming to non-linear data. Handling non-linear data. Non-linear data SVM can handle data that is not linearly separable by mapping it to a higher dimensional space where it can be linearly separated. Mapping to higher dimensions uses kernel functions to transform data into a higher dimensional space without explicitly computing the coordinates. Example of nonlinear problems. Examples include complex pattern recognition, nonlinear regression, and real-world data with complex relationships. Introduction to kernel functions. Role of kernel in SVM. Kernels allow SVM to create non-linear decision boundaries by explicitly mapping data into a higher dimensional space. Type of kernel function. Common kernel function include linear, polynomial, radial basis function, which is RBF, and sigmoid kernels. Now the benefits of using kernels. Kernels enable SVM to handle complex data structures and improve classification performance of nonlinear data. Linear kernel. Definition and properties. The linear kernel is the simplest kernel function. It is used when the data is linearly separable and the classes can be divided by a straight line. Mathematical formulation. The linear kernel is defined as k xy equals to xy plus c, where c is constant. Application and advantage. Used in text classification and other application where data is linearly separable. It is computationally efficient and easy to interpret. Now, polynomial kernel. Definition and properties. So, what is polynomial kernel? The polynomial kernel is a non-linear kernel. It represents the similarity of vectors in a feature space over polynomials of the original variables. So basically, the similarity of vectors in a feature space over polynomial of the original variable. The mathematical formulation, the polynomial kernel is defined as k xy equals to xy plus c, where c is constant and d is the degree of the polynomial. Now, applications and advantages. Used in natural language processing and image processing, it can handle non-linear data and model complex relationships. Now, radial basis functions kernel. Definition and properties. The RBF kernel is a popular non-linear kernel. It maps the data into an infinite dimensional space. The RBF kernel is defined as kxy, where gamma is a parameter that determines the speed of the kernel. Applications and advantages. Widely used in various applications such as pattern recognition, image processing, and bioinformatics. It can handle non-linear data efficiently. Then, sigmoid kernel. Definition and properties. The sigmoid kernel is a non-linear kernel derived from neural networks. It is also known as the hyperbolic tangent kernel. The sigmoid kernel is defined as where alpha and c are kernel parameters. Application and advantages. Used in neural network and machine learning application, it can model non-linear relationship and is computationally efficient. So this is it. Thank you.